again, and we're going to continue to talk about section 6.1, solve equations. First of all, what is an equation? Well, an equation just means that two algebraic expressions. You have expressions on the left-hand side, expressions on the right-hand side. So you join those two algebraic expressions with an equal sign. Example here, let's say x minus 2 equals to 4. 3x plus 4, let's say, equals to 1. And x minus 3 equals to 2x. So those are two in each of the equation, two algebraic expressions are equated by an equal sign, right? So solution to an equation just means that you find the value of the unknown, okay? So solve an equation, of course, meaning that you carry out the steps to find the solution to the unknown, to the value of the unknown to the as a solution to the equation, okay? So let's look at the example here. What we first is trying to understand what do we mean by a value is a solution to an equation. So example here is we want to determine whether 2 is a solution to the equation as shown here. Or what we need is to check. We need to check if left-hand side equal to right-hand side by substituting 2 for x. So if we find after substituting 2 for x, the left-hand side equals to the right-hand side, then we can claim 2 is a solution to this equation. So let's check. Left-hand side, so we're gonna substitute 2 for x. So left-hand side equal to 3x squared plus 7x minus 11, right? So we're gonna, whenever see x, I'm gonna replace that by 2, okay? Again, here 3x squared means 3 multiplied to 2 squared, and plus 7 times 7x means 7 times x, so 7 times 2 minus 11, okay? So continue. I need to calculate 2 squared first, so that's 4, so 3 times 4 plus 7 times 2 minus 11, okay? Now I need to calculate multiplication. 3 times 4, that's 12, and then 7 times 2, that's 14, and minus 11, okay? Then I calculate the addition and subtraction from left to right. So 12 plus 14, that's 26, minus 11, and that's obviously 15. So the answer is 15. And you see, after plugging x equal to left-hand side actually equal to 15, obviously this is equal to the right-hand side. So therefore, you conclude 2 indeed is a solution. Of course, here we talk about a solution to this equation, right? So linear equation, it just means that the largest exponent of the variable is 1. So example, x minus 2 equals to 3. So x is actually equal to x raised to the first power. So so the 1 That's the exponent, right? The equivalent equation just means that two equations have the same solution. Example here, let's just put it, say, x equal to 1, 2x equal to 2. And those two equations are equivalent because each equation has the same solution, x equal to 1, right? So solving equations, the key idea is isolate the variable, okay? Typically, you isolate the variable, typically on the left-hand side, okay? So that involves that you perhaps if you have a term with a variable on the right-hand side, you're gonna need to move that to the left-hand side. Now, you cannot just move it arbitrarily. What you do is you always want to keep um, equivalent operations. In other words, when you move a term from one side to the other side, you do not want to change the solution to the equation. So you're gonna need to use a number of properties. So first one, let's quickly look at it, is so-called the addition property. So it's fairly simple. If you got an equation A equal to B, you can add the same constant to the both sides. It won't change the solutions to the equation. Okay, so fairly simple. But let's look at an example how to apply this addition property to solve a linear equation. So x minus 8 equal to 12. Notice that the x is already on the left-hand side, but negative 8 is not a term with a variable, and we need to somehow move it to the right-hand side, right? So again, we cannot arbitrarily move it. We need to maintain the equivalence of solutions to the original equation. So what we do is we're gonna apply the addition property. So we add 8 on both sides. So that won't change the solution to the equation. Why we do this? Well, because negative 8 plus 8 is 0. So that one leads to the left-hand side becomes just x. Well, the right-hand side now is 12 plus 8, 20. That gives me actually immediately the solution. So you see, we can use this addition property to solve a linear equation. Second, the property is called subtraction, actually similar to the first property. When you have an equation, you subtract same constant from both sides. It won't change the solution to the equation. So let's see how we apply this property. So let's see, x plus 11 equal to 19. Again, we have 11 on the right-hand side. We need to move it to the left. On the left-hand side, we need to move it to the right-hand side. Well, again, here, what we're gonna do is the following, okay? So I'm gonna subtract 11 from both sides. This won't change the solution. However, as you can see, 11 minus 11, that's 0. So the left-hand side becomes x, and right-hand side, 19 minus 11, that's just 8. So that's why we do this, because by this way we can solve for x. The third property is also fairly simple. If you have got an equation, you can multiply both sides by the same constant, but it's to be non-zero, by the same non-zero constant. And then this way you will not change the solution. Okay, you don't want to multiply both sides by 0, for example. If you multiply by 0, you get 0 equals 0. So you kill all the equations. equation. You kill all the information. Of course, you won't be able to solve the solution, solve the equation. Okay, so let's see. Suppose we want to solve this equation. Solve this equation. So what we're gonna do is this. Okay, so we're gonna divide both sides by 7, and this way give me x just equal to 5. So fairly simple. That's why we do this. Okay, so let's look at the next slide. So turning a little confused here. So we're having to solve this. So determine solution to x equal to 4 equals to 8, right? So I'm gonna write down the equation, and what I'm going to do is multiply both sides by 4, okay? And this way I can, the 4 divided by 4 is 1. So I get x on the left hand side, and right hand side is 4 times 8 is 32. So you see it's very effective. Okay. And the division property is when you have an equation, you can divide both sides by a non-zero constant, and that won't change the solution to the equation. Okay. I already talked about this example, 7x equals 34. You divide both sides by 7, you get x equal to 5. So we can summarize some general procedures for solving linear equations. Number one is if you see fractions, what you do is you want to eliminate the denominator. To do that, you multiply both sides of the equation by the denominator, or sometimes by the lowest common denominator. This is what we did earlier. Okay, so the idea is to eliminate fractions. Typically you need to remove parentheses. Okay, so to do that, you will apply the distributive property, and a lot of time you need to combine like terms. And lastly, remember the key main goal to separate or to isolate terms on one side. So to collect word terms with a variable on one side and collect terms without a variable on the other side. So that's the main goal, the key idea here. And eventually you're going to end up with ax equal to b, of course. With that, you can solve for x. So you divide ax, divides both sides by a, and that gives you x equals to b over a. All right, so let's quickly look at this example here. 3x minus 5 equal to 28. Our goal is to isolate the terms with the variable x, okay? Meaning that we need to somehow move this term to the right-hand side. Now, what we can do here is, you probably already know how to do it, is and 5 on both sides, right? And 5 on both sides. That won't change the solution. However, negative 5 plus 5 is 0. So the left-hand side becomes 3x, and right-hand side 28 plus 5 is 33. And then you divide both sides by 3, and that gives you x equals to 11. So you see how we use the idea of collect terms with x on the left-hand side and collect terms without x on the other side, and then you can, combine like terms and so on, and find the solution. Okay. So let's quickly look at this example. 60 plus 11 equal to times t plus 6 minus 5. Okay. So let me copy the equation here. Okay. So when you see this, typically the very first step is to remove the parentheses. Or to do that, you need to apply the distributive laws of 2 times t, 2t, and 2 times 6 is 12, minus 5, right? And then let me try to change the color. So then what we need is we need to move 2t to the side, and we need to move 11 to this side, right? So that's a general idea, okay? So let me change the color to red again. So let me copy 60 plus 11 equals to 2t plus 12 minus 5, right? So to move 11 from left hand side to the other side, what I can do is subtract 11 from both sides, right? And then to move 2t to the other side, what I can do is minus 2t from both sides, right? So now you see that 11 minus 11 becomes 0, 2t minus 2t becomes 0, and I have 60 minus 2t, that's 4t left on the left-hand side. And on this side, I have 12 minus 5, that's 7, 7 minus 11, that's minus 4, and then obviously t equal to negative 4 divided by 4 equals to negative 1. So that would be the solution. Okay? Let me quickly talk about what do we mean by an equation with no solution. Well, if you simplify the left-hand side and right-hand side of an equation, you end up with a contradiction, then that indicates that the original equation has no solution. Okay, so example here, let's look at an example here. This complicated example. So let's look at this equation here. On the left-hand side, let's look at the left-hand side. I have this, right? So if I simplify it, I would first expand or remove the parentheses. So I have 3 times x, that's 3x, minus 3 times 5, that's 15, plus x plus 12, right? So if I combine like terms, 3x plus x, that's 4x, and then I combine negative 15 plus 12, that's negative 3. So the left-hand side is that. Now let's look at the right-hand side. Right-hand side equal to 6x minus 2 times x plus 2. Again, I open the parentheses, so minus 2x, minus 2 times 2, that's minus 4. And then I have 6x minus 2x, that's 4x minus 4. Now you see the left-hand side is 4x minus 3, and right-hand side is 4x minus 4. There's no way for the left-hand side equal to the right-hand side, right? So because if 4x equals to 4x minus 3 equals 4x minus 4, then you can remove or subtract 4x from both sides. You end up with minus 4 equal to minus 4, which is a contradiction because it never can be true, right? It's a contradiction, which means the original equation is a contradiction, has no solution. Okay? So what do we mean an equation with infinitely many solutions? Well, it just means that you reach an identity. Left hand side is always equal to right hand side. So let's look at this example here. We got an equation here, and if we simplify the left hand side, I have 2x plus 8 minus 3x plus 15. Now the right hand side will be minus x plus 23, right? So the left hand side, if we continue to simplify it, combining like term 2x minus 3x, that's minus x, and a plus 15, that's 23. And notice the left hand side is minus x plus 23. So the left hand side, right hand side is are identical. So this is called an identity, meaning that any x is a solution. Any x is a solution. So therefore, this equation has infinitely many solutions. Okay. So again, we talk about identity just means that it's always true. In this case, that all real numbers are solutions. All right.